Hi, so what we're going to look at is just some images of planes. So here we have a coordinate axis, a 3D coordinate axis. And so what you will see here is, here, let's put it like this. Oh. Okay, so we've got like an X, a Y, and a Z axis. And if I put an equation of a plane here, okay, and let's just flip this around so we can see it. There we go. So I did X plus Y plus Z equals 4. So if you can see where it's going through here, each of the axes it's going through the point 4. So, and that is because if we put like 0 in for the X and the Y, then the Z would be 4. If we put 0 in for the X and the Z, so these are 3 points on the graph. If we change this to be, say, a -1, then this would be going down here through -1. Now, sometimes we have planes that are missing a value. So let's just look at a plane, just say it's at X equals 2. Oh, I put Z. That's fine. Just change the color so that you can see it. Okay, so what I put in was Z equals 2. So where's the Z axis? It's up here. And so that goes through at Z equals 2. And so that would be sort of level or parallel to the X and the Y axis. Okay, you can see that it's parallel to those. Okay, and so what would X equals 5 look like? Oh, here, we can change the color. I accidentally took the axis out. There we go. Okay, so here's X equals 5, so that would go through at X equals 5, and you can see that it is parallel to the Z and Y axis. So how do you get a plane right through one of those axes? Well, if I change that to be X equals 0, X equals 0 is actually the plane. Let's take this one out so you can see. It is the plane right through the Z and Y axis. Okay, that goes through at X equals 0. We could have, for example, Z equals 0, and we could put Y equals 0, and that would give us. Let's make this one into a color. So that is a plane through each of them. And where does that plane intersect? Well, it intersects at the point 0, 0, 0. That's where they all cross, those 3 planes. Okay, so you can see how that works. And that's what we'll be talking about now. I'm going to show you some different images, and we're going to talk about how they intersect. And so let's just get rid of these for a minute and put another plane in. A random plane. I might modify it if I don't like how it sort of looks. Okay, so here it is. So it's just a plane with a sort of different slope. And the slope in what we think of as like a slope of a line is sort of the normal vector, which is 2, 3, -1 in our case, if you look at the numbers in front of the X, Y, and Z. So here's that plane. And then if I added another plane to this, Okay, and let's just change the color so we can see the two. Okay, and so here's two planes, and I just made up two different planes, and here they are in 3D. We can take the axis out if you want to just see the planes themselves. Okay, so here's two planes, equation 1 and equation 2, and you should be able to notice that they would cross. Where they intersect is a line, and so two planes can intersect at a line. Now, what if I added a third plane to this? Let's just change the color so we have three different colors. Okay, it's going to be a little bit harder to see. Let's just move this around, and you can see that they do intersect, but they intersect where? Not at a line. In fact, if I take out this one for a minute, those two intersect at a line. You can see the line. If I take out the pink one, you see these two intersect at a different line. And if I take out the blue, you see these two intersect at a different line. So two planes, as long as they don't have the same slope, they do intersect at a line. But when I put 3 in, they all intersect sort of at a point. And can you see that they would intersect at this point right here, whatever that is? Let's put the axis back in, and maybe we will see where they intersect down here somewhere. Okay, so it's a little bit hard to see where they intersect, but here it is. And when we're solving systems of equations, if you had 3 equations, then they could intersect at a point. Let me put another plane in here, and then I'll get rid of one of the others. Let's go with this. Okay, so I'll get rid of one of the others. And so now I have 2 planes, but you notice what I did over here. So equation 5, x plus y minus z equals 0, and then I added equation 6, which is still the same thing on this side, x plus y minus z, but I put it equal 3 instead. And so what you'll see happens is that the green one goes through 0 for our value, and the blue one goes through at 3. Those are parallel. And so now these 3 equations don't have a solution. So because the pink one does cross both, but if we're looking for a solution for all 3, they don't have a point that intersects. Okay, so that would be another. And of course, we could have, say, 3 equations that that are parallel. Oh, let's move it a little bit. A little further. I'm just trying to make it further apart. There we go. Okay, and let's just change the color of this one. There. And so I've made 3 parallel planes. And you see I didn't put the same lead. So if you look over at equation 6, it's x plus y minus z, but then here I put 4. But I just multiplied this whole thing by 4, and then I changed the number on the other side. And you notice when I changed it, if I made this bigger, it will go further away. And if I make it smaller, it will go closer. And I could actually make it coincide, so it would be the same as another equation. And so you'll see you can't tell the difference now. The color got darker because there are two that are coinciding. Equation 5 and 7, if I get rid of everything else, equation 5 and 7 are here. If I take equation 5 out or put it back in, they are the same equation. What did I do? I just multiplied equation 5 by 4, and so it is actually the same equation. Okay, so let's go away from this and take a look at some different graphs that I have in OneNote. So I'm just going to make this a little bit bigger so we can see. Okay, so if we have two planes, then they can intersect at either a line, so I showed you that, or they could be parallel, or they could coincide and be actually the same planes. So you wouldn't be able to tell the difference. So that's if you had two planes. Now, if you have three planes, let's look at the different options, and we explored a few of those. They could all coincide. So then every point on the plane or any of those three planes would be a solution. Two could coincide. So here it says plane 1 equals plane 2, so we can't sort of see that, but they two coincide and one doesn't. And so the intersection would be what? The intersection of that would be a line. So that would be your intersection point. So we could have two coincide and one parallel, and this would have no solution because the three graphs or the three planes don't intersect at any common area. 4, we could have two parallel and one intersecting, and anytime there is any parallel, there'd be no solution between the three. Two of the planes, these two planes intersect at a line, and these two planes intersect at a line. So these are like the solutions if we only had the two, but all together there's no solution because all three don't intersect at a common point or line. All three are parallel, no solution, they don't have any overlap. All three meet at one point, and that's a little bit harder to see, but here is the point where they all intersect. So that would be the solution is a unique point. So we'd say that is one solution or a point. Then 7, they all meet at a common line. So this could happen where they all meet at a line. So this would be the line is a solution. And remember, a line in 3D is x, y, z equals, and then we have a point plus t times the direction vector. So, or you could write this in parametric form, but that line would be the solution. And then 8 says the line of intersection of any two is parallel to the third. So you see it's sort of like triangular, and there are these two planes intersect here, these two planes intersect here, and these two planes intersect here, but all together there's no solution because they don't all intersect at any plane. And so what this is saying is that line of intersection of any two is parallel to the third. So you see these are parallel, they lie on the same plane, but they don't share a common point. Okay, so then the last thing I want to show you here is that if we were to say draw planes, so x equals 0 is the y, z plane. So if we have x, y, and z, then x equals 0. This are negative x go in this direction, negative y, negative z. And so these are the positive x values. But if we're saying x is 0, that's right here. And where we would actually see that is this plane. So it goes through okay, so this is called the ZY plane. So there is nothing here sticking out, and in behind there is nothing along that. And so that's what that would look like. And then so if we had y equals 0, this is the XZ plane. So y equals 0 is here, and that plane XZ is sort of here. And it does not go on the y-axis at all. Oh, sorry. You can't even see what I'm doing. There we go. Okay, so it doesn't go on the y-axis. And then similarly, if we had z equals 0, this is the xy plane. So what if we had x equals 1? Well, this goes through x equals 1, and it is parallel to the YZ plane. So if here is x equals 1, then this plane goes through at the point x equals 1. Okay, and sort of hard to draw, but you might be able to get the picture that it doesn't go back here at all. Okay, it only goes through at x equals 1. Okay, so it's parallel to that plane. Okay, so let's go back over to the calculator for a minute. And let's look again at these. So let's take out these others. So here is z equals 0, and I said that that is the x, y plane. So you see that that doesn't, it just goes through z equals 0. But if I change that to be z equals -5, then that goes down. Well, -5 isn't even on this graph, so let's move it up a bit. -2. Okay, so it goes through at z equals -2. It is parallel to the x, y plane. Okay, now what if we had two variables like x plus y equals 3? So let's see where that is. So here's x and y, goes through 3 on both of those, but it doesn't cross the z-axis at all. You see that that is parallel to the z-axis, but it isn't parallel to a plane, just to the z-axis. Okay, and you can play around with this if you go to this website as well. So if we took, say, 2x minus z equals 3, let's make it a different color. Actually, we'll take out this other one. Okay, so the letter that's missing is the Y, and you'll see that this crosses both the X and the Z, but it doesn't cross the Y. It is parallel to that Y-axis, so it doesn't cross the Y. So when a variable is missing, that's what would happen. Okay, so I'm going to leave you with that. There's a couple questions on the WebWork homework that this should help you with, and good luck. Let me know if you have any questions.